There is a sound, a very specific, sickening one. It's not just the clatter of metal against pavement, it is a sharp, dense crack, followed by a hollow ringing that seems to echo in your stomach long after the noise is stopped. You know exactly what this moment feels like. Your hand slips, your fingers grasp at empty air, and suddenly, the most intimate object in your life, the silent keeper of your memories, your conversations, your connection to the entire human race, is in free fall. For a fraction of a second, time seems to stop. You watch it tumble, and then it hits the ground. Most of us simply close our eyes, bend down, and turn the device over to see if our world has shattered. We see the spider web of cracked glass, we let out a sigh, and we move on. We accept it as bad luck. But it isn't bad luck, it is physics, and what actually happens in the space of that single catastrophic millisecond is a story of profound violence, invisible forces, and a microscopic war that is fought and lost right in the palm of your hand. To truly understand this, we have to look closer. We have to strip away the illusion of time. In this simulation we've built, time is no longer our master. We are going to stretch one single second into a lifetime. We are going to freeze the frame right before the point of impact and step inside the architecture of the disaster. Look at the phone as it hangs mere millimeters above the concrete. To us, it is a sleek monolith of aluminum, silicon, and glass. But to the unforgiving laws of physics, it is a heavy package of kinetic energy. As it falls, gravity accelerates it. The mass of the phone, multiplied by its velocity, generates an invisible, immense power. And the universe demands balance. The first law of thermodynamics dictates that energy cannot be created or destroyed. It can only be transferred. When the corner of your phone touches the concrete, the falling stops, but the energy doesn't. In our simulation, as the impact occurs, watch the colors bloom. This is the shockwave. It is a brutal, silent earthquake moving at the speed of sound through the materials of your phone. The point of impact takes the first crushing blow. The aluminum or titanium frame compresses. To the naked eye, the metal feels completely rigid, but here, in the microscopic realm, we see it behave like a liquid. It ripples, it bows inward, desperately trying to absorb the force. But metal can only swallow so much. The remaining kinetic energy has to go somewhere, so it travels upward. It rips through the frame and crashes into the internal organs of your device. It violently shakes the battery. It tears through the motherboard. The motherboard is a miniature metropolis of silicon chips, copper traces, and microscopic gold wiring. When the shockwave hits this city, the board actually flexes, it bends. Thousands of tiny solder joints, the fragile bridges connecting the processor to the memory, the camera to the screen, are instantly stretched to their absolute physical limits. If the wave is too strong, these tiny bridges snap. That is why sometimes a dropped phone looks perfectly fine on the outside, but refuses to turn on. Its internal city has been leveled. But the motherboard is hidden. The tragedy we care about, the one we mourn, is the glass. Let's look at the screen. As the shockwave reaches the front of the phone, it enters a material that defies logic. We call it Gorilla Glass or ceramic shield, but this is not the glass of your windows or your drinking cups. This glass is a masterpiece of modern alchemy. To understand why it shatters, you must first understand why it usually doesn't. If we zoom into the atomic level of the glass, long before the phone was ever dropped, we would see a material in a constant, agonizing state of tension. When this glass was manufactured, it was bathed in a vat of molten salt at over 400 degrees Celsius. Inside this blistering chemical bath, a microscopic trade took place. Smaller sodium ions abandoned the glass, and larger potassium ions from the salt forced their way in to take their place. Imagine a subway car perfectly filled with people. Now imagine forcing 30 more giant bodybuilders into that exact same car. The walls would bulge, the pressure would be immense. Everything is tightly packed, pushing violently against everything else. In material science, this is called compressive stress. It is an ingenious piece of engineering. Because the surface of the glass is constantly pushing against itself, it forms an invisible armor. If a key scrapes against it, or if it takes a minor bump, the internal tension pushes back, preventing a crack from forming. The glass is incredibly strong, precisely because it is deeply stressed. But this brilliance is also its fatal flaw, because all that pent-up energy, all that tension locked inside the subway car is just waiting for an excuse to escape. Let's go back to the moment of impact. The shockwave hits the edge of the glass. The glass is bending. Yes, glass bends. In our slow-motion simulation, you can see the flat surface warp inward like a trampoline under the weight of the kinetic force. If the glass is perfect, the compressive stress holds, the trampoline bounces back, the phone survives, you pick it up, wipe off the dust, and breathe a sigh of relief. But perfection is a myth. Think about your daily life. Think about the pockets you slide your phone into, the tables you set it on, the bags you toss it into. The world is covered in a material called quartz. It's the primary ingredient in ordinary sand. And quartz happens to be harder than the chemically engineered glass on your phone. Over months of use, microscopic grains of sand have carved invisible trenches onto the surface of your screen. You can't see them, they're thinner than a human hair. But in our 3D landscape, these microscopic scratches look like massive, jagged canyons cut into the armor. When the phone bends during the drop, the shockwave seeks the path of least resistance. It races across the surface of the glass until it finds one of these microscopic canyons. And right there, at the bottom of an invisible scratch, the armor fails. The compressive stress that gave the glass its strength suddenly turns on itself. The tension is finally released. The shattering doesn't happen randomly. It is an explosion. From the epicenter of that microscopic flaw, a fissure rips open. It propagates across the screen at 3,000 miles per hour. That is 4 times the speed of sound. Faster than a bullet. Before the phone is even finished settling onto the pavement, the glass has torn itself apart, creating a frantic map of interconnected fault lines. The energy has finally exhausted itself. The universe has balanced its equation. The simulation stops. We return to real time. You bend down, you pick it up, you turn it over. There it is, the spider web. It's easy to feel frustrated when this happens. It feels like a betrayal of technology. We pay $1,000 for a device, expecting it to be invincible, expecting it to be perfectly insulated from the chaos of the physical world. But perhaps the shattered glass is a reminder of something deeply human. We carry these glowing rectangles everywhere. They're the first thing we look at in the morning and the last thing we see before we close our eyes. We project our lives into them. We pour our secrets, our anxieties, our bank accounts, and our relationships into their circuits. We treat them as extensions of our own minds. We expect them to be permanent. But they're just objects, fragile, physical things, bound by the unforgiving rules of nature. They are subject to gravity. They are vulnerable to friction. They wear down, they scratch, and eventually, they break. The next time you drop your phone and you flip it over to reveal a shattered screen, don't just see a broken piece of technology. See the history of its survival. See the immense invisible forces that fought to keep it whole right up until the very last millisecond. See the tiny flaws, the hidden scars that ultimately brought it down. Because in a way, running our thumbs over the cracked glass of a phone we refuse to replace is a very quiet, very modern form of acceptance. It is an acknowledgement that nothing is invincible. Not the metal, not the glass, and certainly not us.